Welcome back to our MSIX series. In this video, we'll dive into the critical topic of digital signing for MSIX packages. Now, I know I probably reiterated this in most of the videos until now, but digital signing is essential for ensuring the security and integrity of your MSIX packages, and unlike any other packaging formats until now, this is a mandatory step in the packaging process. Without a digital signature, an MSIX package cannot be installed under any shape or form, unlike MSIs or EXEs, where the user account control, the UAC, might pop up and show you different colors if that specific package is signed or not. One of the main benefits of MSIX is security-driven architecture. This is provided first by the app container, and second by the fact that each MSIX package carries a digital signature. As mentioned, over the past 2 decades, digital signing was only optional for most packaging formats. So now Microsoft imposes this as mandatory. While there is a developer mode setting in Windows that allows for unsigned MSIX packages to be installed, this is not intended for production use. So why should you sign an MSIX package? Well, the operating system uses the digital signature to verify the package origin and ensure it hasn't been tampered with. Digital signing attaches a hashed value of the package contents, validating that the files have not changed since the signing. Because the signing process uses a private key from your certificate, nobody else can alter the file without invalidating the signature. If an attacker tries to tamper with the package, the digital signature will break and the system will reject the package. Generally, applying a digital signature is done using a tool like signtool.exe from the command line. You specify the files to sign, the certificate used for signing, and other configurations. Signtool reads the publisher field from the Apex manifest file and compares it to the subject field in the certificate. To simplify this process, many packaging tools, including the Microsoft Packaging Tool and Advanced Installer, provide a graphical user interface to handle this digital signing, abstracting the command line options to save your time. But where do you get the certificate from? Well, you have 3 main options. You can use a self-signed certificate, meaning you can generate a self-signed certificate and deploy it to the machines where you want to install the application. This is often managed through PKI and group policies in enterprise environments. You can buy a code signing certificate from a trusted certificate authority or CA like VeriSign, Komodo, and other stuff like this. And this ensures that any Windows OS will recognize the certificate. And then you have your Azure code signing service, which is a free service from Azure requiring an Azure tenant. The Azure administrator enables the service and it starts on its use. Self-signed certificates are typically used within an enterprise, while purchased certificates are ideal for software vendors distributing packages publicly. Azure code signing is convenient for those already using the Azure services. Now, when you get your certificate, extract it to a PFX file and protect it with a password. This ensures that the PFX file cannot be used to sign files without a password. Keep the password secure and only share it with your trusted individuals. For third-party packaging, use cross-signing techniques to sign packages with an untrusted certificate first, then re-sign them with your trusted certificate. Certificates expire, and it's crucial to add a timestamp during the signing process. This ensures the package remains valid even after the certificate expires. Without a timestamp, the package will be considered invalid once the certificate expires, and it's going to prevent new installations. Also, Signtool can communicate with a public CI timestamp authority to validate the signing time, storing this information in the file. This process confirms that the file contents haven't changed since signing and that the signing occurred while the certificate was valid. Furthermore, Advanced Installer now supports trusted signing, making the digital signing process even more seamless. Trusted signing simplifies acquiring, securing, and using code signing certificates. It's integrated with Azure, and this feature allows secure access management for certificate profiles throughout your Azure tenant. This integration not only streamlines the signing process, but also sets a new standard for secure software distribution. Whether you're a developer or an IT professional, trusted signing in Advanced Installer makes it easier to manage your certificate and sign your packages securely. Now, if we open up Advanced Installer, as mentioned, and go to the digital signature page, once we enable the signing, we have 5 options to choose from. You can use a certificate from your own store on your own machine. Here I have only one, but you can also create a new one if it's necessary. This is only for testing purposes. You can use a file from disk, and this is where you choose your PFX file, like I mentioned. You can use trusted signing. You need to configure your endpoint, account name, certificate name, and correlation ID. You can use from Azure Key Vault to sign the package. You need to put your tenant ID, app ID, value name, certificate name, and certificate version. And last but not least, you can use device guard. For each of these 3, let me show you how easy it is to use them. Thanks for watching. Don't forget to subscribe for more insights into MSIX packaging. Join us in the next video as we continue exploring tools and techniques for efficient application deployment. See you next time.